Okay, we're going to start our new unit now, which is on the poverty of the stimulus argument. And this is in some ways the centerpiece of the Chomskyan generative linguistics program. And it's mostly concerned with syntax and with first language acquisition of syntax and how children learn syntactic generalizations. Of course, to understand any of these arguments, we're going to need to have some basic knowledge in place about syntax. So, this lecture is going to be a review of basic properties of syntactic theory. Now, for those of you who have taken a syntax class here at WVU, a lot of this will probably be, or not a lot of it, all of it will be basically review to you. It might be worth checking out this lecture anyway, just because it will come at it from maybe a slightly different angle, and it will emphasize certain aspects of basic syntactic theory that are going to be important for this unit. So I'd encourage you to take a look. If it's super boring and you're like, I already know all of this, then it's fine to skip it. The next lecture will be going through some specific poverty of the stimulus arguments in different areas, and then we'll eventually focus in narrowly on a bunch of really narrowly syntactic structure-dependent generalizations. So that's what we're up to now, and let's just start with a sort of basic intuitive understanding of what syntax is and what it's for. So pre-theoretically, we might describe syntax as the system of rules or generalizations about combining words to make sentences. And that's not wrong or anything, but it misses a number of pretty important points about why we have a theory of syntax and what that theory is meant to describe and to characterize, right? So, in an intro linguistics class, and actually maybe even in the intro syntax class, you've probably seen some kind of a rule system for English that might look a little bit like this. And this is, again, a toy grammar. This is not the full grammar of English, but it's the kind of thing you might find in a textbook or in an intro class when you're going through the idea of, hey, it's not just that we string words together. There's an important ways that parts of a sentence break down into other parts. And so we read these rules. They're called rewrite rules. And they're going to start with some kind of a top level symbol. It's abbreviated S here for sentence, which is a little bit old fashioned. For those of you who have seen more modern syntactic theories, you know that sentence has been replaced by some different other kinds of notions. And it says that the thing on the left can be rewritten or decomposed into the things on the right. So a sentence, according to rule 1 here, consists of a noun phrase followed by a verb phrase. And then, well, what are these noun phrase and verb phrase things? According to this particular toy grammar, a noun phrase consists of a determiner like the or a followed by a noun. And a verb phrase can consist of a verb followed by a noun phrase like saw the dog, or it can be just a verb as in, ate, or it can be a verb followed by a prepositional phrase, and so on and so forth. And we keep doing this over and over again and say these phrases over here also break down into some kinds of categories. And this is basically taken to be a description of a native speaker's knowledge of how English words and phrases combine to make sentences or something like that. And it's definitely a useful way to remind students of how phrases are typically formed in English so that they can draw trees in their homework assignments. You want to basically follow these phrase structure rules that you've been given and show us how the sentence, the quick brown dog jumped over the lazy fox, can be diagrammed as a tree structure so that you can get 100% on your homework. But of course, this is not meant primarily within linguistics to be a teaching kind of exercise. This is meant to reflect the subject's knowledge of how their native language works. And the question is, well, why these rules? Where did we get these rules from in the first place, and why are we stating them this way, right? And so there's two important aspects of phrase structure or of syntactic grammar that are the common threads amongst all syntactic theories, that are the most basic facts that we're going to need to capture in any theory of syntax. So I'm going to go through these two sets of important properties. One of them is about headedness, and I'm going to go through that first. And then the second set of facts is about constituency, and that's absolutely crucial. It's the kind of basic thing that any theory of syntax is going to need to capture. And while there are differences in the specific details of how people think about syntax, even within the Chomskyan framework or the generative syntax kind of a framework, these basic facts are things that everybody agrees on. So let's think about phrase structure a bit. One of the questions here in syntactic theory is going to be, hey, why are some strings of words grammatical in English, like very difficult problems giving me trouble, while other strings of words are not grammatical? So this is marked again with an asterisk here. In syntax, this means ungrammatical sentence. Not a grammatical English sentence. Problems very difficult. Give trouble me. Right? So these two strings of words contain the exact same words, but they're in different orders. And one string of words in a particular order is a part of English grammar, while the same words, but in a different order, are not a part of English grammar. And so one sort of first thing you might say when you look at facts like these is, well, that's because this one has a coherent meaning. We know what this means, but this one doesn't have a coherent meaning. And I think that's probably not quite right. In fact, we're sure that that's not quite right. Why is that? Well, I mean, actually, if you look at this, problems very difficult, give trouble me. There's no trouble understanding what that means. It's actually quite clear what I'm trying to say there. It just happens not to be the way that syntax works in English. It's just not generated by the grammar. It's not that you can't assign a meaning to that string of words. It's kind of easy to assign a meaning to that string of words. It just happens not to be a sentence of English. Right? So we've been stating all of this here as being generalizations over strings of words, where string of words basically means an ordered set, 1, 2, 3, 4, 5, 6. So the string-based theory here would be the string 1, 2, 3, 4, 5, 6 here is generated by English. That's a perfectly good English sentence. But the string, I'm not going to be able to do this quickly, 3, 1, 2, 4, 6, 5 is not a grammatical string. And so our grammar is going to be stated over numerical sequences. You can have, a intensifier, adjective, noun, verb, pronoun, noun kind of a structure, but you can't have this other kind of a string of words here. And one of the most basic facts about syntactic theory is that string-based theory is not enough, right? And so we don't ever even, very rarely even entertain such a theory in intro classes. We hop straight to the real alternative, the phrase structure alternative. But why is that? Well, here's how we know that the structure of a grammatical sentence is not just a string of words. It has meaningful and coherent subparts, right? So very difficult. It's easy. You can assign a meaning to that phrase, very difficult. It's a coherent subpart. Very difficult problems. Again, that has a coherent meaning. It's something that you can assign a meaning to and a structure to. Give me trouble, right? That's a predicate. It means a particular kind of thing. It's a coherent grouping of words, right? Rather than just being strings, there are coherent and less coherent groupings of words internal to these sentences, and that's basically constituents. Each of these coherent subgroupings itself is built around a particular kind of word, right? So for instance, a very difficult problem is a kind of problem. So again, this is the sort of short version of why we think that there's phrase structure in syntax. And these are all stated with regard to English, but of course this is going to be true in every single language, right? There's going to be some kind of generalizations here about what the meaningful and coherent subparts of a sentence are and what kinds of items they seem to be built around. So how do we know what's a phrase and what's a head? The answer to all of these questions is going to have to do with distributions, the distributions of different categories or items within the grammar of a language or within the set of grammatical sentences in a language, right? So we said something like a noun phrase is built around a noun, a verb phrase is built around a verb, etc., etc. That's inherent in those phrase structure rules that we started with, right? And another way of putting this in terms of distributions, where distribution here just means, hey, where do these different elements occur in the set of all grammatical English sentences? And so the distribution of a phrase The claim here is going to be that the distribution of where noun phrases can occur and can't occur is determined by its head, by the head noun that the noun phrase is built around. Right? So this is why we have headedness in syntax. It reflects the idea that the distributions of bigger items or elements, like phrases, is in some ways determined or predicted by the properties of the heads of those phrases, and that's why we call it a noun phrase or a verb phrase in the first place, instead of just calling it a string or a phrase. It's a phrase of a particular type. Right? So what do we mean by that? Let's take a look here at the verb phrase never eat a hamburger and at the head verb eat. Right? And let's compare. So never eat a hamburger here has this word never, which I'm going to refer to as an adverb, although you could probably argue about that one way or another. It doesn't really matter for our purposes, whatever the category of never is. And it also has a noun phrase, or if you've taken syntax, you might want to call this a determiner phrase. Again, doesn't really matter, whatever the category of a hamburger is. Right? So we label this phrase, never eat a hamburger, as a verb phrase and not as an adverb phrase or a noun phrase or a determiner phrase, even though it contains all those other words, because of the ways that the distribution of the phrase, VP, mirrors the distribution of the V, eat, and not the distribution of the adverb never or the noun hamburger or the determiner a. Right? What do I mean by that? Okay, so let's take a look. Here's a place where the verb phrase can appear and the verb can appear. So vegetarians eat, perfectly good, generated by English grammar. Vegetarians never eat a hamburger, also perfectly good. So grammatical verb phrase, but not grammatical to just put an adverb here. Vegetarians never, not an English sentence. Vegetarians a hamburger, not an English sentence. Vegetarians a, not an English sentence. Vegetarians hamburger, not an English sentence. The idea here is that if you want to predict where this verb phrase never eat a hamburger can appear in English, it's going to appear in most of the context that the verb eat appears in. And the distribution of this phrase is not determined by the adverb or the determiner or the noun in it. It's determined by the verb in it, right? So the distribution of the phrase mirrors the distribution of one of its elements, here the verb eat, in a way that it doesn't mirror the other elements inside the phrase. That's how we know the verb is special in this phrase. That's how we know it's a verb phrase. Here's another data point here, another place where, again, the goal of a vegetarian is to eat. So the verb can appear in this particular context. And as we predict, the verb phrase can also appear here. The goal of a vegetarian is to never eat a hamburger. This is now a different context than we started in, but we see across this other context, you can find the verb here. Therefore, you can also find the verb phrase here. Compare this again to the other elements in the phrase. You can't put the adverb in this context. It's ungrammatical. The goal of a vegetarian is to never. Doesn't work. You can't put the determiner or the noun or both of them in this context. The goal of a vegetarian is to a hamburger, right? Not a grammatical sentence of English. So again, the distribution of this phrase, never eat a hamburger, mirrors the distribution of one of the elements inside it, eat, in a way that it doesn't mirror the distribution of these other elements, the adverb, the determiner, or the noun. That's why it's a verb phrase. We can also look at contexts where it's ungrammatical to put the verb there. So here's an ungrammatical place to put a verb. Vegetarians eat go to Five Guys. Five Guys is a burger place. There's one in Morgantown. As we would predict, if the grammaticality of the verb phrase is determined, or the distribution of it is determined by its head, eat, then we predict the verb phrase shouldn't appear here either. And indeed, that's exactly what we find. Vegetarians never eat a hamburger, go to Five Guys, equally ungrammatical. Compare this again to the adverb. This is grammatical here. Vegetarians never go to Five Guys, perfectly good sentence. You can't substitute in never eat a hamburger for never, but you can substitute in never eat a hamburger for eat without changing the grammaticality of a sentence. Similar example using the determiner and the noun here. Ungrammatical, vegetarians don't love eat. And so as we would predict, the verb phrase is also ungrammatical there. Vegetarians don't love never eat a hamburger. And again, easy to assign a meaning to that sentence. It's just ill-formed because of English grammar. It's just ill-formed in syntactic terms. But the determiner noun combination here is grammatical. Vegetarians don't love a hamburger, completely fine. So again, you can substitute in the phrase never eat a hamburger for the verb eat without changing the grammaticality or ungrammaticality of an English sentence, but you can't do the same thing for never eat a hamburger, substituting it for a hamburger. This is how we know that eat is the head of the phrase. This is what headedness is about in syntactic theory. It's ultimately about distributions. Excuse me. So, that was an example with the verb phrase, and of course there would be a similar set of facts for the noun phrase, the adjective phrase, the prepositional phrase, etc., etc. And I'm not going to go through every step of this here, and of course there's some trickiness and some subtleties, especially with prepositional phrases. But the basic idea is that this is where headedness comes from in our syntactic theory, is from observing parallels between the distributions of phrases and the distributions of the words that head them. Right? So briefly, for the noun phrase here, we can say things like vegetarians devour seitan. Seitan is a kind of fake meat substance made out of, I think, gluten. And so, yeah, if we can put the noun seitan there, then we can also put the noun phrase, the tasty seitan in the jar. No problem. Vegetarians devour the tasty seitan in the jar. Grammatical sentence. But we can't take the other elements from that phrase, as in the, or tasty, or the tasty, or in the jar. We can't substitute those elements in while preserving the grammaticality of the sentence. And so just like the verb example, we're going to end up saying that the distribution of this string, the tasty seitan in the jar, is determined by its head seitan, not by the or tasty or in or the or jar. And therefore, this is a noun phrase because it mirrors the distribution of its head noun, not a determiner, an adjective, a preposition phrase. Right? This is the basic idea here. And the same thing is going to be true, changing what needs to be changed across all these other categories. So far, so good. That is headedness. Headedness is a basic property of syntactic knowledge, of syntactic representations, that any theory of syntax is going to have to account for. These are facts about their native language that every native speaker implicitly knows. Right? So that explains why we think that these phrases have heads and why some elements are heads and others are not. That is why phrases are of a particular type. It doesn't explain why we think there are phrases in the first place, though. And so that's going to be the topic of constituency. And this is the second thing that I'm labeling kind of most basic facts about syntax and syntactic knowledge. Right? So in a sentence like this particular more or less random English sentence below, observation here is that not all groups of words are equal. What do we mean by that? Well, I'm going to go into elaborate detail about this in a moment. Here's the sentence. A large mouse ate the French cheese on Tuesday. This is, again, perfectly grammatical English sentence. And here's what we're going to do here. Here's how I'm going to illustrate what I mean by saying not all groups of words are equal. We're going to look at two groups of words that are contained in this sentence. One of them is a large mouse, and one of them is cheese on. And so we're going to show through a series of tests that these two sequences of words don't function the same way in the grammar, that there's a difference between them. And of course, those of you who know a little bit about syntax, probably most of the others as well, can sort of intuit a large mouse here is a coherent, meaningful subpart of this sentence. We're going to call that a constituent. Right? You can say what a large mouse is. And you can imagine putting this in different sentences in different contexts versus this sequence of words, cheese on, is not a coherent, meaningful subpart. It's not a constituent, right? So that's sort of appealing to our inherent or intuitive notions of what things mean. or of how coherent they are, but there's a more formal and more precise way to do that kind of a test as well. What is that? Well, here's our two strings, a large mouse and cheese on, and we're going to compare them. And the way we're going to do this in syntactic theory is to have a bunch of syntactic tests or diagnostics for what makes a constituent versus a non-constituent. And interestingly here, we started out with just grammaticality judgments when we were doing syntax. We're now extending our sort of pseudo-experimental paradigm. These are little tiny experiments that we're doing on ourselves to a wider range of behaviors, namely transforming sentences in different ways and asking about the resulting grammaticalities, right? And this is basically the experimental or empirical data that the theory of syntax is based on. So here's one particular kind of linguistic behavior that any native speaker of English can do. Forming a question and then answering the question. So let's first form the question by removing this string of words, a large mouse. And is there a way to question this statement while removing a large mouse? Yes, there is. It uses this word who. And the question is, who ate the French cheese on Tuesday? What can the answer to that question be? Well, one possible answer is the exact string of words that we're examining here. A large mouse. Who ate the French cheese on Tuesday? A large mouse. Perfectly well formed in English. Compare this to our other sequence of words here, cheese on. So first of all, there is no obvious way to even form a question by leaving this element out. Here's my sort of best attempt. What did a large mouse eat that was French Tuesday, or something like that? Any way you can think of forming this question, it's never going to have a well-formed answer. Cheese on, right? That is just not a possible answer to this or any other question based on this sentence in English. Now, of course, you might be able to find some crazy context or ambiguous meaning where cheese on is a possible answer to some question from some sentence, but not from this sentence, importantly. No question based on this sentence can have the answer cheese on. So what is this telling us? This is one kind of evidence that these three words, a large mouse, form a coherent element in a way that, for instance, cheese on does not. So we're going to say we're going to use the term constituent to label the property of being a coherent, meaningful subpart of the kind picked out by these tests, and not some other kind of subpart like cheese on. So that's test one. This is sometimes called the fragment response test. There's lots and lots of diagnostic tests in every language, and they differ to some extent from language to language. Worth saying as well, this doesn't only work for a large mouse or a noun phrase, it also works for verb phrases, prepositional phrases, etc. So here's the example with a verb phrase. For instance, ate the French cheese on Tuesday. That's a verb phrase. Can we form a question while taking out this element? We can. What did a large mouse do? And can the answer be this string of words? It can. What did a large mouse do? Ate the French cheese on Tuesday. Perfectly well-formed response to that question. And compare, for instance, a subpart of that string with just the words ate the French. And again, what did a large mouse do to the cheese on Tuesday? Ate the French, right? Where this phrase, ate the French, can actually be an answer to some questions in English, but certainly not this one and not based on this original sentence. It means something very different when you say that ate the French. And so, yeah, this is a sort of funny example, but it's illustrating a real point here, which is simply that, again, some strings of words form coherent groupings internal to a sentence, ate the French cheese on Tuesday, in a way that other strings of words in this particular sentence do not. Ate the French. Ate the French could be a coherent subgrouping in some other sentence, but not in this one. Here's a prepositional phrase example with the sequence of words on Tuesday. And this forms a coherent subgrouping in a way that cheese on Tuesday does not. Here's the illustration. Here's the WH question, taking out this prepositional phrase and then giving it as an answer. When did a large mouse eat the French cheese? On Tuesday. Perfectly fine. Compare cheese on Tuesday, which we think is not a constituent. What did a large mouse eat the French one of and when? And so again, we're having trouble even thinking of a question that you could make out of the sentence like this. But whatever question you come up with, the answer is not going to be cheese on Tuesday. So again, showing that this kind of constituency test works for other constituents as well. Maybe not every kind of constituent in English, but many of them. This is just the adjective version. I will leave you to take a look at this on your own if you like. Here's a second kind of diagnostic test. And this one is sometimes called the substitution or pronominal substitution test. So again, we're going to go back to our original example of a constituent, a large mouse, versus non-constituent, cheese on. Here's a second diagnostic that converges on the same answer. Can you substitute in a pronoun in English for this sequence of words, a large mouse? And if you can, then it suggests it's a coherent subgrouping. So in English, yes, you can. You can substitute in it, right? So the way I've done this here is to try to conjoin two sentences. And this is in order to make sure that you're actually getting the parallel structure in the two sentences, that you're really substituting in the pronoun for this particular string of words in this sentence. And so I've done this by creating a contrastive sentence with the same kinds of elements in it, but substituting in this group of words with a pronoun. So a large mouse ate the French cheese on Tuesday, and it gnawed a hole in my sock on Thursday. Right? Where it here is understood to be substituting a large mouse. Right? Therefore, this is telling us that a large mouse is a constituent, is a coherent subgrouping. Compare cheese on. Right? A large mouse ate the French cheese on Tuesday, and two small cats devoured the bleu it Thursday. Absolutely not, right? So here, again, I'm using this parallel structure to ensure that we're really taking just the noun and preposition out of a context where it's preceded by an adjective and a determiner. So, of course, there would be some way to say this sentence with it afterwards, but it would be substituting in for the whole noun phrase, not this cheese on part. So that's, again, showing us that this is ungrammatical, suggesting that cheese on is not a coherent constituent here, a coherent subgrouping of words. Similarly, we can do this with the preposition phrase, a large mouse ate the French cheese on Tuesday, and two small cats gnawed a hole in my sock then as well, where then is understood to mean on Tuesday. A large mouse ate the French cheese on Tuesday, and two small cats did so on Thursday, where here did so is taken to be standing in for the entire verb phrase, ate the French cheese. And the idea is you keep repeating this for all the different elements in the sentence and see which ones are constituents and which ones are not. Here's a third diagnostic test in English. This is the coordination test, which is a little bit tricky, but the examples I'll give here are pretty straightforward. And again, we're going to go back to our original constituents, a large mouse versus non-constituent cheese on. Here's the point here. You can coordinate the constituents. You can put and in between them. And, you can take the constituent, put and after it, and then put an identical sequence of categories. So determiner, adjective, noun. And this preserves the grammaticality of the original sentence. A large mouse ate the French cheese on Tuesday is grammatical. A large mouse and two small cats ate the French cheese on Tuesday, also grammatical. Compare this to cheese on, right, where you, again, try to put the conjunction and a sequence of noun preposition afterwards does not preserve the grammaticality of the sentence. The original sentence was grammatical, but if you try this operation, the coordination test here, a large mouse ate the French cheese on and butter before Tuesday, not grammatical. Now, in English, there's a separate sort of fact here, which is that you can make this grammatical using a very special kind of intonation. I'm going to ask you to ignore that for the moment and say at least 2.5 of these constituency tests are converging on the same conclusion here. And we can keep doing this and doing this. So this is, again, with the preposition phrase on Tuesday. You can conjoin that with before Thursday, showing that it's a constituent. Ate the French cheese, this verb phrase. Or it's actually a V bar for those of you with more fancy syntactic theory. But you can conjoin this with an identical sequence of verb. Here it's a prepositional phrase, but ate the French cheese and not on my sock. These are all perfectly good applications of the coordination test. Therefore, these are all constituents. So why am I introducing this right now? So introductory courses often, especially intro linguistics classes, and intro syntax class is usually going to be more involved eventually. But intro linguistics courses often take the approach of just telling you that there are phrases and they work in a particular way. So English has these kinds of phrases. Here's a phrase structure grammar that will tell you how to draw trees for English sentences. Learn it for your homework. But the point about syntactic theory here is that both ideas about constituency and about headedness are supported by evidence. Right? These are empirical arguments in syntactic theory, and you need to argue them using constituency and distributional tests. Right? And what those tests usually take the form of in theoretical linguistics is just appealing to a native speaker's implicit knowledge about grammatical and ungrammatical sentences and relationships between sentences in their native language. This is what all of those diagnostic tests are doing up above. And all of the distributional tests we looked at before that, they're using relationships between different possible kinds of structures to argue for containment or headedness relations, as well as constituency relationships between words in a sentence. So this is all a bunch of very intricate, sophisticated knowledge, yet every native speaker of English masters these facts pretty quickly and easily without any explicit instruction at a very young age. And we may not even know we have this kind of knowledge, but it's extremely easy to just generate judgments about whether a string of words is or is not grammatical in our native language that will basically reflect these facts about headedness and constituency. It's a form of implicit knowledge that every native speaker of a language has. So how might we represent headedness and constituency in our theory? If we think this is a part of people's implicit grammatical knowledge, here's how we're going to keep track of this. We're going to try every single string of words in this sentence, not really, but imagine that we did. Every single possible sequence of words of length 1 or greater in this English sentence. And we're going to keep track of which ones satisfy the constituency tests, which ones are grammatical in the constituency tests, and which ones, so like a large mouse was our example, and which ones are not grammatical. Like cheese on is not grammatical. How are we going to keep track of this? We're going to put matched brackets around the elements that do pattern as constituents. So here's, again, our first test. Who ate the French cheese on Tuesday? A large mouse. That's grammatical, so let's put brackets around a large mouse. That has to be a constituent. What did a large mouse do? Ate the French cheese on Tuesday, so it looks like this is going to be a constituent too. So put brackets, matched brackets around this as well. Next test, on Tuesday. When did a large mouse eat the French cheese? On Tuesday, so put brackets around on Tuesday. And keep going, right? Here's ate the French cheese. A large mouse ate the French cheese on Tuesday, and 2 small cats did so on Thursday. Did so is substituting in for this string of words here, therefore put some match brackets around ate the French cheese. Now we're getting brackets nested within brackets. Things are getting pretty complicated, but we're going to keep going and going and going. At some point we tested cheese on here. It didn't work as a constituent, so we didn't put any match brackets around cheese on. And we're just going to do this for every single substring of words in the entire sentence. Right? And I'm going to spare you all of the specifics of that. But if we kept doing this for every single string of words in this sentence, we would eventually end up with sets of match brackets that look basically like this. Right? So a whole bunch of brackets indicating constituents within constituents within constituents within constituents. Right? So if I'm being completely honest here, doing every string of words in the sentence would require a whole bunch of fancier syntactic tests that we're not going to cover here. I'm just not going to get into it. But there are ways to argue for constituency, even for things that are not quite as straightforward as the noun phrases, verb phrases, and prepositional phrases I've been telling you about. So just for full disclosure, it would be a little bit more complicated than I've made it seem here. But in the end, you will come out with something that looks like this record of what kinds of constituents we've found in the sentence. This is pretty hard to read. This is sometimes called bracketed notation for constituency structure, and it's kind of hard to look at this and pick out exactly which sequences of words have a matched number of left and right brackets around them. It's confusing to look at. And so often, for visual ease, when we're writing down our hypotheses about constituency, we won't use this horizontal bracketing notation because it's kind of hard to read. We'll often instead use a notation that separates things out into two dimensions in order to make constituents easier to see. So what does that mean? Well, it's going to be mathematically equivalent to the bracketing structure that we've been looking at. So you could write an algorithm that would take you directly from these bracket notations to what we'll call a tree notation. Except it's going to be visually easier to parse, right? So that's absolutely the same theory of an English speaker's implicit knowledge about constituency. It's just that it's visually easier in one form, visually harder in the other. So what's the exact mathematical equivalence here? Constituents are all and only those strings surrounded by matched numbers of brackets, right, in the bracketing notation. And so you just need to transform that into a visual representation where constituents are all and only those strings exhaustively contained under some node in the tree. For those of you who have some syntactic theory, those are technical terms, but visually it's very easy to understand what this means. Here is the tree notation of this bracketing structure. So for every group of words that has a matched number of brackets around it, left and right brackets, for instance, ate the French cheese, will have, you can get it so that there's 3 right brackets on this side and 1, 2, 3 left brackets on this side. Therefore, it's a constituent. The equivalent in this visual form is that there is some node in the tree that dominates or is above all and only the words ate the French and cheese. So this is the constituent in the tree. This bracketing structure is the constituent in this notation, but these two theories, these two representations, are mathematically identical, right? So they're the same thing. We find this one easier to look at. Now, obviously, I'm missing something in here compared to normal syntactic trees from syntax class. In general, headedness is also reflected in these trees. So we add in these higher level nodes here, end up with the labels of whatever element internal to them determines their distribution. That is their head. Right? So for instance, ate the French cheese. We saw this earlier with never eat a hamburger. The distribution of that phrase across different kinds of sentences in English is going to be determined by the verb eat and not by the determiner the adjective French, or the noun cheese. So in this node here, the constituent that contains all of these, we're going to write that it's an eat phrase or a verb phrase, right? So we normally put VP up in this node, and we do that filling in for all of the other nodes in the tree as well, up until this top node, which would be labeled sentence, or whatever your equivalent is in your theory. This is another reason why we use tree structures, because putting those labels in on the higher level elements here is going to be much easier in this visual form. It's going to make this tree equally easy to read, versus here you're going to have to put them in little subscripts around either the left or the right brackets, and it's going to make things even harder to read. Right? So this is how we get headedness and constituency into our theory of syntax. In fact, this is exactly what tree structures are. They are charts of constituency. They're not the form that we think actual sentences take in somebody's mind, or God forbid, in their brain. These are just ways of writing down for the linguist where the constituents are that we found in this sentence. Right? So these phrase structure rules that we started out with way back up here, where are those? That we find in textbooks um, are actually constraints on what possible tree structures we might find in English. So while these might look like pretty simple principles, there's actually a huge amount of evidence and argumentation and complicated formalism behind reaching these generalizations. Right? These are very broad grammatical principles, and it takes a lot of work to get to these, looking at the details of how English sentences work, right? All of the constituency testing and headedness testing, everything we've been doing for this lecture is sort of collected into general principles like this that we put in our intro syntax or intro linguistics class. Um, that took us a while, and I'm speeding this up greatly. Normally it'd take a month or two to do this in a class. And so the question becomes, how do children learn all of this? This is a huge amount of information and intuitions and implicit knowledge. How do kids get there? And this will be the final part of this part of the lecture. I'll briefly go through what you might expect to be a simple and easy and nice theory of how syntactic generalizations could be learned. Here's a common sense view of how kids could learn phrase structure, and this is going to be related to some of the papers we looked at earlier, especially the Safran, Aslin, and Newport paper, where they showed that very young infants can track statistical dependencies and patterns of what comes after what within sort of simplified linguistic experiments. So what's going to happen here? Children will hear strings of words in their environment when they're very young. They will fail to hear other strings of words very much. The child keeps track of which strings of words have gone together frequently and which ones have not. Right? This is just like learning the Tibudo, Pabiku kind of language in that Safran, Aslin, and Newport experiment, except now we're talking about words instead of syllables. Right? And we know infants are able to do this statistical learning because we've seen it in experiments. So they're going to track, hey, these strings of words tend to occur next to each other, and this string of words, usually I've never heard this at all, or I've heard it very infrequently. So this is a completely associationist domain general theory of how we're going to get syntactic structure. The child ends up with a database of something like transitional probabilities between words, how likely different kinds of words are to follow one another. And they're going to eventually use that knowledge to implicitly construct a theory of constituency. Once they have that, that's going to allow them to distinguish between well-formed and ill-formed linguistic objects, and that's how we get to be adults who have strong intuitions about grammaticality that all seem to mirror constituent structure. So here's a slightly more concrete example of how this could work, although it's still going to be leaving out a bunch of details. But here's the basic idea. How do we get to the point of being adults that know things like this? I'm presuming that nobody in this class, unless you've seen these slides before, has ever considered this particular English sentence with these particular word subsets before. Yet we all instantly sort of get that a large mouse and two small cats ate the French cheese on Tuesday is a part of English grammar, while a large mouse ate the French cheese on and butter before Tuesday is not a well-formed part of English grammar. So how did we get to be adults who know this? Well, here's an infant, I guess it's not an infant. I guess it's an adult. It's us at this point. We're looking at these or hearing them and saying, oh, well, I've frequently heard determiner, adjective, noun together. Determiner, adjective, noun. And, I know that sequences that go together a lot, like determiner, adjective, noun, can be joined together by words like and. And so I'm going to say this is fine, because these are coherent units that I've heard together a lot. And two of these coherent units can be joined together by and. Right? That's the basic idea. I might not have heard this particular sentence before, but I've heard, thousands of times in my life, determiner, adjective, noun occurring one after the other, and I've heard thousands of times in my life two coherent units joined by and. Compare this. Therefore, I'm going to say this one is good. Right? That's how I learned to do these kinds of judgments, and this is where my judgments come from, is my experience with sets of things co-occurring in my input data. And the same thing could apply to a child. Compare this to the non-constituent she's on. How do I know that that's bad? Well, I've certainly heard noun preposition before, but not as frequently as determiner adjective noun. And I've put a question mark here to indicate that this is actually already pretty questionable, but let's assume that's right. That, yeah, these are just less frequent sequences that I haven't heard together as much. And in particular, I've rarely or never heard two sequences like this joined by the word and. This just hasn't happened much in my input. Therefore, I'm going to judge this one bad because I haven't heard these kinds of elements co-occurring in this way before. I'm going to say, nope, not my grammar. Right? And this is basically exactly the same way as we think infants might have learned the words tibudo and pabiku in that Safran, Estlin, and Newport experiment by tracking which things go together, which things don't go together, and by giving some special status to things that co-occur frequently while denying that status to things that don't co-occur as frequently. So this is how we get to be from an infant that knows nothing about English syntax to being an infant that has all of these subtle constituency judgments that allows us to construct an implicit theory of English syntax for ourselves. Right? This is a beautiful, beautiful theory because it doesn't rely on any special universal grammar. It does rely on you having separated words from one another and having learned the categories of those words. Maybe some of that will require some innate kinds of biases or structure to be in place, but the actual syntax itself, figuring out how words go together, how constituent structure works, relies only on pattern recognition and statistical learning. And these are general human capabilities that we already know children have and that we've seen that they use in all sorts of day-to-day tasks. So this would be no special language-specific innate abilities at all. And that's great. And there's also no need here for any particularly fancy cognitive machinery at all. It's just the ability to track things that go together and things that don't go together. So this is a beautiful, simple, nice theory of how you can get from an infant that knows nothing about syntax to really pretty subtle and fine-grained judgments that will that reflect how children learn constituent structure. So this is beautiful. This would be a problem, though, if we could show for sure, if we learned that there was patterns of syntactic knowledge or generalizations about synchronic grammar that every mature language learner possesses. That is, it's part of our collective grammar here, implicit knowledge of language, but for which there is little or no evidence in the linguistic input that they've been exposed to. All right, so basic property here of this kind of account is I've had experience with these kinds of sequences before, and that experience had enough, the input here that I've been given, people speaking around me as an infant, as a small child, as an adult, as whatever, that input has been rich enough that I've heard things like this many times and not heard things like this as many times, and I've come to fairly confident knowledge about which one of these is more common and therefore is going to be more of a structural entity than the other, right? I have to have a bunch of experience in my input in order to have figured this out. If we could show that people possess knowledge like constituency structure, but without any evidence in their input, that would be a big problem for this empiricist theory of syntactic learning. Right? So nothing that we've looked at so far, this constituency and distributions and headedness, seems like it would necessarily be a giant problem for empiricist syntactic learning. So maybe we don't need any special language-specific innate UG in order to do syntactic theory, unless a situation like this arises, where we can show that every adult speaker, native speaker of a language, knows something about their language that they could not have learned from their input. This kind of case, of course, I wouldn't be telling you this if there weren't proposals or claims that such cases exist. And in particular, Noam Chomsky claimed that there are many such cases in every language. And his name for the situation is the poverty of the stimulus. Where, what does that mean? Well, the stimulus here is going to be the language learner's input, what you've heard as an infant or as a child. And the claim in these particular cases, which we'll get to shortly, is that that input is not rich enough in the details you'd need to have seen in order to learn the adult grammar. Therefore, the input is impoverished in the kinds of data or language input that you'd need to see. Um, the next part of this lecture, I will go into some specific cases where poverty of the stimulus has been claimed in different places, and we'll look through some of them.